Okay, so this we'll be studying later in your wave optics. Okay, so please understand that when some ray is going like this, right, it's going to go towards the normal. So you know that the speed is changing. Okay, but you should also know that what happens to the wavelength and the frequency. Okay, so any idea what happens to the frequency and wavelength? Frequency remains the same. Okay, wavelength only changes. Okay, so take it down. So let's say this is velocity v1, nu1 is frequency, lambda1 is wavelength. When it comes here, the second medium, the velocity decreases, nu remains the same, and lambda2 is also going to decrease. Why? Because they may ask you some question. So the frequency remains same. Frequency remains same. And they may ask you why. The answer for why is, you should say that the frequency depends upon the source. Okay. So I will show this later in your wave optics. Okay. But for now, if you want to understand a little bit, let me see if I have that wave thing. So some of you who were there and I taught you the 11th, probably you remember this. So when you want to see a wave, right, what you can do is, you can just do something like this, horizontal, where can I do this? Okay, so I hope everyone can see it. So if I did it like this, right, that's a wave, right? I'm generating a wave here and then the wave is carrying the energy to the other end. So wave is nothing but a disturbance or carrying energy, okay? A method to carry energy from one point to another. So you see, so my hand movement is only this way, but the wave is going this way. What do you call that kind of waves? Transverse or longitudinal? Transverse, right? When this and this are 90 degrees, then it is transverse. Okay. So that means, so look at this. When I do it like this is looking a little bit slow, right? If I do it like this, what did I change? The frequency, right? So the frequency is determined by the source. Okay, so it doesn't determine, it's not dependent upon the medium. So make a note. I don't know if I can show it in a vertical way. No, it doesn't work very well in the vertical. So frequency remains same because it is determined by the source. Okay, so it does not change because of the medium. Whereas you have studied that the velocity changes, right? That means compared to this, the velocity here is going to be smaller, right? So look at the formula. What is wave equation? V is equal to nu lambda. That is your wave equation. So all these things you have studied in your 11th standard, so I think it's already evaporated. Nobody is answering. So if I say this is constant, right? If this increases, what do you think should happen to this one? It should also increase. And if this decreases, it should also decrease because this is a constant. What's the issue? No book. You don't bring the book, what can you do? Keep sitting also. Where is your book? Don't have the habit of bringing books. So that means If the speed here is lower, the lambda will also be lower. So take it down. So if V2 is smaller, lambda 2 will also be smaller. When I say smaller, comparing it to the V1, right? You are comparing it to this medium. That's all. So they are asking, how does the refractive index of a transparent medium depend on the wavelength? How to answer this? Do you know any relationship between refractive index and the velocity? What is it? Are you using n or mu? I think we are using n, right? N is equal to c by v, right? So that means, so refractive index is v1 by v2, something like velocity in the first medium, velocity in the second medium. So according to this formula, I can say it's nu into lambda naught divided by nu into lambda. So nu are both are same, which means it will be lambda naught by. So refractive index is equal to, so this is your first medium. If you want, you can call it as lambda 1 by lambda 2, whatever you want to write. Okay. Generally, since it is air, you can write it as lambda naught and c. Okay. Velocity of light in glass is 2 into 10 power 8, air is 3 into 10 power 8. If the ray of light passes from glass to air, calculate the value of critical angle. So how to find the value of critical angle? Any formula which you know? Sin IC is equal to 1 by n, right? So sin IC is your critical angle is equal to 1 by n, refractive index, right? So this is refractive index 2, 1. This number should always be bigger than 1. Okay? So they are asking you to find the critical angle. So how to find this? The velocity has been given, this and this are given, which means you can find this. So what will be the refractive index of glass? 1.5, because it is 3 divided by 2. 10 power 8, 10 power 8 cancels. Look at the question. Only if you see the question it will make sense. So that means refractive index n is equal to c by v. So c is given as 3 into 10 power 8. V is 2 into 10 power 8. So 10 power 8, 10 power 8 cancels. So it is 1.5. So put it over here. So sin IC. So maybe I can write it here. So sin IC is equal to 1.5. So IC is equal to, sorry, 1 divided by 1.5, right? Sin cannot be greater than 1. So this will be sin inverse of 1 by 1.5, so whatever it is. 1 by 1.5 will be 2 by 3. So it will be, you see 1.5 is 3 by 2. So the reciprocal will be 2 by 3. 2 by 3 is 0.6. So the approximate value is 0.5 is 30 degree, right? Half. So 0.7 is 45 degree. 1 by root 2 I told you, right? 1 by root 2 is 0.7. So that means it's somewhere in between 30 and 45. So that's all I can say for now. If you want the accurate number, you have to use your tables. Okay? Or else you will have to give some approximate numbers. So for now I can say somewhere between 45 and 30. So somewhere around 37 point something. And you can double check in the so that is 31. Okay. Let's do 29. A ray PQ incident normally on the refracting face BA is refracted in the prism BAC made of material of refractive index 1.5. So the refractive index of this prism is n is equal to 1.5. PQ is incident normally. What do you mean by normally? 90 degrees, right? Which means it's not going to bend. It will just go straight. Okay, that's the important thing to remember while doing ray diagrams. So only if it is having some angle like this, it will do refraction. If it is going straight, it will not be doing any refraction angle. Of course, the speed will reduce, but then the angle will not change. Complete the path of ray through the prism. From which face will the ray emerge? So they are given this as 90 degree, this as 60 degree, which means you should know this is 30 degree. So when this goes here, it's going to go straight like this, right? So this is the incident ray, right? So this is my incident ray inside the glass. This is 30 degree and this is going to be 90 degree. So what can you say about this one? 60 degree, right? And then at every surface I have to draw the, what do you call this line? Normal, right? So that means this is my angle of, this is 60 degrees, so that means this must be, what do you call this angle with the normal? Angle of incidence, right? So we are talking about this point, this is angle of incidence with the normal, right? Because this ray is coming inside, so I am talking about angle of incidence here. So that means you know that it's going to do refraction and reflection. Okay, so reflection is very simple, so it's going to come out like this, which is 30 degree. Okay, I is equal to R. But now the question is it going to do any refraction or not? So denser to rarer. So will it go towards the normal or away from the normal? Away from the normal. But then before that, they said the refractive index is 1.5. So for 1.5, I think somewhere from your theory knowledge, right, you should know that the critical angle is, anybody remember the critical angle for glass? I have given it to you. Theory. 24 is for diamond. 42 something I should have given, right? So that means only if it is beyond 42, if the incident angle is beyond 42, it will be doing total internal reflection. Which means here it will not be doing any total internal reflection. So it will be coming out like this, and then it will be coming out like this here. So everyone following that? So you can say that the emergent ray is going to come out from AC. Let me give the labels here, A, B, C. Okay. Is that clear? Any doubts? So this is straight and it's coming and hitting here. So this is, use the triangle method and then use the triangle calculations, 30 degree and then 30. So since 30 degree angle of incidence is less than critical angle, no total internal reflection. Only if it is beyond IC critical angle, you will see total internal reflection. They may change the numbers over here. So suppose if this was 60, right, and if this was 30, then what will happen? This would become 60. If this was 60, what will happen? Then it will be total internal reflection because it is greater than 42 degrees. Okay. So I asked you to remember these critical numbers. Okay. So 42 degrees is for glass and the refractive index is 1.5. And for diamond it is 24 degrees. Water also I given you some number, I don't remember, 45 something. Anybody remember the number? Water it is 1.33. 1.33 is refractive index. Critical angle 48. Okay, so you have to remember these three numbers because very often you will be getting glass, water, or diamond. diamond is very rare. Okay, so that is 29. 30. Read the 30th question. Can I erase this one? So anybody having any doubts in this? If you have any doubts, please ask me immediately. Doesn't matter how silly it is, clarify it immediately. If you keep it to yourself, then you are going to suffer later on. I'm sure you already should have experienced this during your half-yearly exam. Okay. So if you don't study it then and there, then you are going to suffer. Okay. Use the mirror equation to show that on object placed between f and 2f, a concave mirror produces a real image beyond 2f. So I'm sure from your 10th standard you know that between f and 2f, it will be forming an image beyond 2f. So if you keep the image here, right? So you should know that it will be forming beyond 2f, right? And beyond 2f means it will be between f and 2f, right? So now they are asking you to prove it. Use the mirror equation to show this. Okay, if it was a ray diagram, it's easy to show because you have practiced this in your 10th standard itself, right? You would do something like this, and then it will go through f, and then if something is going through this thing, it will be coming through like this, so it will be forming somewhere here. Okay, diagram is not perfect. It will be forming somewhere here like this. Okay, that's what it will do. But then now they are asking you to do it by mirror equation. So what is mirror equation? 1 by f is equal to 1 by u plus 1 by v. So how to prove it using mirror equation? So easy method is, I am supposed to prove that the image is formed beyond 2f, right? So what is the image distance there? U or v? V. That means let's find out the v first. So 1 by v is equal to 1 by f minus 1 by u, right? So 1 by v is equal to u minus f divided by fu. So v is equal to fu divided by u minus f. Is that correct? So now see, it's very simple. Suppose if I keep the object at f, right, where will the image be formed? Infinity, right? So look at this. If I put u is equal to f minus f is 0, which means anything by 0 is infinity. So v's image is formed at infinity. Okay? So when u is equal to f, v is equal to infinity, image at infinity. Right? So when u is equal to 2f, right? So first I am talking about the first extreme this way. Then the next extreme is this point, right? So let's try what will happen if I put u is equal to 2f. So if I put 2f here, 2f minus f is f. So v is equal to fu divided by 2f minus f. So fu divided by f. So ff cancels. So v will be equal to u. So that means if I keep the object here, it will be forming here. You agree? So in this extreme it was forming at infinity. In this extreme it is forming here, which means between this and this it should be forming between infinity and 2f. Following that? That's all. So that's what you are supposed to write. So you should say that okay, let me attempt this and come. So first try the, but you are allowed to use the extreme conditions and say okay, when it is at f it is infinity, when it is at 2f it is at 2f, which means the image should be formed between infinity and 2f. That's the way you have to prove. By that way, you are saying that anything between this and this, it will be found between infinity and 2f. You following that? Just for your easy understanding, I did it like that, 1.5. But you are not supposed to do it in the exam like that. So try the 32. 32 is the easy one. An equiconvex lens of focal length f is cut into two identical plane convex lenses. How will the power of each part be related to the focal length of the original lens? So equiconvex, so it's like this. So we're cutting this into two halves, so that means this is, what do you call this lens? What would you call this? This is equiconvex or biconvex. This is plano-convex. This is plane, this is convex. So it's called plano-convex. So if you make it into two halves, right? So let's say this is power 1, this is power 2, this is actual power original, right? So read the question again. How will the power of each part be related to the focal length of the original lens? So that means, so you know that P1 plus P2 is equal to P0, right? Suppose if I keep these lenses together, we have studied a formula, P is equal to P1 plus P2, right? But what can you say about P1 and P2? Will it be same or equal? It's different. It will be same, equiconvex, right? So we are cutting it into half, which means it has to be the same. That means I can say 2 times P1. So that means this will be the relationship. Or you can say P1 is equal to P0 by 2, meaning the power is half of this. So that's the first part. Okay. So as I told you earlier, right? So there is no integration, no differentiation, nothing, right? So if you know a little bit of trigonometry and some formulas, you can very well do all these problems. Okay. If you are not doing it, it's just your laziness. Okay, you are not doing enough effort. I already given you, I told you many times, this is the best book available out in the market. Okay. If you are not doing that, then it's your laziness which is causing your problem. Double convex lens of plus 5D is made of glass of refractive index 1.55 with both faces of equal radii of curvature. Find the value of its radius of curvature. So what do you mean by plus 5D? What is that? Is it focal length or power? Power. What do you mean by D? Diopter, meaning meter power minus 1. That's the meaning, right? Instead of writing it as meter power minus 1, we write it as diopter. Okay. And they are asking you to find the equal radius of curvature. So they are asking to find the radius of curvature. So what formula do you know which involves radius of curvature and refractive index? Lens maker's formula, right? So 1 by f is equal to n minus 1, 1 by r1 minus 1 by r2, right? They said radius of curvature is equal, right? So that means what can you say about r1 and r2? They are same, right? Do you know f? Power is given, so that means I can say 1 by 5, right? Because power is equal to 1 by f. So that means in place of 1 by f, I can put 5. N is given as 1.55. So 1.55 minus 1. Yeah, good question. So think about it. What is the radius on this side? It is on this way, positive. What about R2? This way, which means negative. So it will be minus R2. That means here it will become 1 by R minus R. So minus and minus will become plus. So So it will be 2 by r. So this is 0.55. This is 5. So r is equal to 0.55 into 2 divided by 5. 0.22 meters. So that means it is 22 centimeters, right, into 100. So generally all these lenses, it's good to write it in centimeter also in addition to meters. Okay. Very simple if you know the formula. Okay, try 33. Very similar ray diagram based problems. So here, did you write the theory properly? I didn't write it here, but I expect you to write it properly. So 33, two monochromatic rays of light are incident normally on the face AB of an isosceles right angle prism ABC. The refractive indices of glass prism for the two rays 1 and 2 are respectively 1.35 and 1.45. Trace the path of these rays after entering through the prism. Okay, this is little bit, you have to do little bit of thinking. So let's see. So it's not a easy direct formula method. Okay. So let's see. It says isosceles, which means this is 45 degree. This is also 45 degree. This is 90 degree. So the refractive index of glass prism for the two rays 1 and 2. So this is one ray, this is second ray, right? It's something like one is red laser, the other one is green laser, right? What do you mean by monochromatic? Same color, right? One single color or one single wavelength. Okay, so that's what monochromatic means. So refractive index of the glass prism for the two rays is given as, so N1 is given as 1.35, N2 is given as 1.45. What do you mean by this? I thought for a given glass you will have only one refractive index. How come you have two refractive index? It varies with the wavelength, right? So generally what we have been studying so far is something like a common thing, like an average. Okay, so if you send a white light, what happens? Right, so it's more like an average thing. You see, it's still very close to 1.5, but then you have a different numbers, right? Why do you think? Why did we say that the prism, right? Dispersion. Which one bends more, violet or red? Violet bends more, right? Why do you think violet bends more? Violet has got less wavelength, which means the refractive index is actually more, yeah, right? So the refractive index for violet is more, okay, compared to the red. So I think we have some other problem for that. Let's see. Okay, coming back to this. So both the rays are going to go straight. Why? Because it is incident normally. No doubt in that. Right? So after this, what happens? That's the question. So this is normal. This is normal. If this is 45, this is 90. What can you say about this one? This is also 45. That means this is also 45. Agreed? That means it will be coming out like this because this is also 45. Right? So now the question is, will it do some refraction or not? Okay. So if the critical angle is 42 degrees, then it will not do any refractive. Let's have to, it's given as 1.35. So only for 1.5 I told you it is 42 degree, right? For 1.35 I don't know what is the critical angle. Are you following it? So for when n is equal to 1.5, I told you the critical angle is 42 degrees approximately, right? That means for according to the formula, sin IC is equal to 1 by n, which means if this value is actually smaller here, so that means this overall value will be bigger, which means the critical angle will also be bigger. Okay. For this, the critical angle will be greater than 42 degrees. You follow it or not? Let me repeat it one more time. So if I put 1.5 here, right? So I will be getting some value. For that, IC is given as 42 degrees. Using your calculator or tables, you will be able to find this. But now what I am saying is, suppose if I put 1.35 compared to 1.5, 1.35 is bigger or smaller? Smaller, which means the overall value will be bigger. If this value is bigger, the angle will also be bigger. Because I told you sinus, as the angle increases, the value will also increase. Whereas the cos it is other way around. So it means IC is greater than 42, but I don't know the actual IC value. Right? In the case of 1.45, I don't know, same thing. In the case of 1.45, it's higher means. So how can I do this? So what is the angle of incidence here? I is equal to 45, right? All I have to do is, if I know the critical angle for this, I'm done, right? So how to find the critical angle? So I can say sin IC is equal to 1 by n1, right? IC1. So that means 1 by n1 is 1.35. So sin IC1. So IC1, if I want, I should do sin inverse of 1.35. Right? Using your tables, you may have to find this and check the IC value. Or the other option is, right? Suppose if I take sin 45, I know sin 45 is equal to 1 by root 2. Right? 1 by root 2 is nothing but 1.414. Right? So if it is 1.44, right? Sorry, 1.414, then the critical angle will be 45. You agree? If it is 1.35, so if I put 1.35 here, this value is smaller, the overall value will be bigger, which means it will be more than 45. So that means the critical angle for this is more than 45. Okay. So IC1 is more than 45. But the angle of incidence is only 45. So will that be any total internal reflection? No. Right? Which means there will be some ray coming out this way also. So that's, instead of going straight like this, it will be going away from the normal. Does this make sense? Okay, so you have to do a little bit of thinking like this, even though I don't know. So either if you have the tables, you can directly do it like this. Okay, find out the IC1 and then see whether it is greater than 45. Make the addition. Okay. If you don't have the tables, then you will have to use this kind of method. Now look at this. For 1.4, it is 45 degree. For 1.45, what will happen? 45 is actually, so this overall value will decrease. If this decreases, this angle value will also decrease, which means the IC2 will be less than 45. So IC2 will be less than 45, whereas the angle of incidence is still 45, which means angle of incidence is greater than 45. Angle of incidence greater than 45 means, is it TIR or not? Angle of incidence is greater than IC, which means it will be TIR. So that means no. So it is total internal reflection. Here you say no TIR. Okay. So take it down, all these things. Bit confusing, but you have to try it. Okay. Basically, you are playing with the numbers. That's all. Checking whether it is greater than IC1 or not. Okay. If doesn't make sense, don't worry, just take it down and try it again in your home. Anybody having any doubts? If you want, I can help you with any steps. Okay, so this is not a straightforward question. Okay, you have to do a little bit of thinking. Some of the things are very straightforward. So if you apply the formula, you will get the answer. Okay, so I think 35 is theory. So we already done it in the theory. 36 is also theory. Rainbow, I have given you all the theory questions. 37, try it yourself. It's based on the same logic which you have been using. Try it. Let's try 38. A convex lens of focal length f1 is kept in contact with the concave lens of focal length f2. So convex is f1, concave is f2. So this is convex, this is concave. Find the focal length of the combination. So what is the focal length of the combination formula? You know, P is equal to P1 plus P2, or you can write 1 by F is equal to 1 by F1 plus 1 by F2. But then concave lens, is it positive focal length or negative focal length? Concave, negative, right? So if you see the concave lens, so it will go something like this, right? So something which is coming here, it will get diverged like this, which means where do you think it will focus? It will focus on the back side, which means F is negative. So that means for concave, you have to write it as 1 by F1 minus 1 by F2. Convex, it will focus on this side, right? So it is positive. So that's all for 38. Very simple. 39. So read the thing. I think it's the same thing what we did at the very beginning. When monochromatic light travels from a rarer to denser medium, explain the following giving reasons. Is the frequency of reflected and refracted light same as the frequency of incident light? The frequency same or different? Same. Why same? Because frequency is dependent upon the source. So it doesn't depend upon the medium. So I already given you the reason at the very beginning. Does the decrease in speed imply a reduction in the energy carried by light wave? So this again we will study later. Okay. So I think it's coming in wave optics. So the energy of wave depends upon the frequency. Okay. Which means when the frequency remains the same, what can you say about the energy? Energy will also be the same. So that's your answer. So take it down for now. We'll study more about this later. But as I said, sometimes they may combine questions from different chapters. So you should say the energy of a wave depends upon the frequency. So as frequency is same, energy will also be same. Forty is a theory question. Write the necessary conditions for the phenomenon of total internal reflection. So what is total internal reflection condition? It has to be denser to rarer. That's the first condition. What is the second condition? Greater than the critical angle. Okay. Don't know what is total internal reflection. Go back and take down the notes and study it. Okay. If you are not there, so at least wake up now and take down the notes. If you don't have the notes, then Amrish did a very good dialogue at the. Sir, I went to YouTube, I went to apps. I didn't understand. Okay, if you don't attend the class, then nothing will work. Okay, so all those YouTube apps, this, that, everything is just a all-in-one arihant. Everything is just a additional thing. Okay, if you don't listen to the class, then it's of no use. That's good. At least now you realize, right? Instead of realizing at the end of the year. Some of you are still not realizing that. Okay, go to 41. So whenever I am skipping something, I think I expect you to do it yourself. Okay. So if you are serious about your scores, do it. Otherwise, don't worry. So I'm going to erase this side. So try 41. Convex lens of focal length 25 cm is placed coaxially in contact with the concave lens of focal length 20. Determine the power of combination. Will the system be converging or diverging? Okay, so the first part is very similar to what we did there. So power is equal to P1 plus P2. 1 by F is equal to 1 by F1 plus 1 by F2. So determine the power of the combination, which means 1 by F1 is 1 by 25 minus 1 by 20. Why minus? Concave, right? So if you don't check that out, everything will go wrong. So do this and then you'll get the answer. So it will be, power will be, so 20 minus 25, so minus 5 by 20 into 25. So 5 minus 1 by 100 is your power, right? So that means 1 by F is equal to minus 1 by 100. So F is equal to minus 100. So focal length is negative, right? What does that mean? Is it converging or diverging? Diverging, right? Because it is concave lens. So it acts as a concave. Or in other words, what it means is, the combination is actually acting as a concave lens of focal length minus 100. Let's try 42. Auditor is also similar to the ray diagrams which we did earlier. Trace the path of a ray of light passing through a glass prism ABC as shown in the figure if the refractive index of glass is √3. Then find out the value of angle of emergence from the prism. So you have something like this. You have a normal incident ray like this. ABC is here. This is 60 degree, which means this is 30 degree. The refractive index is given as √3. And find out the value of angle of emergence. So follow the same thing. So if it is normal, right, what happens? It goes like this, right? So this is 30 degree and this is 90 degree. What can you say about this one? This will be 60 degree, right? But then I have to always talk with terms of normal, right? So if you don't put the normal, everything will go wrong. If you think this as angle of incidence, everything will be wrong. So this is my angle of incidence. So I is equal to 30 degree. This is 60. This must be 30. And reflected ray is very simple. So simply take it as I is equal to R reflection. R is also 30 degree. So this is always never a problem, right? So it's never a problem. Issue here. The only thing which you have to determine is whether that is refracted ray or not. Okay. So how to determine that? for which you should know the refractive index or critical angle you should know, right? So root 3 is given, so use the formula. So sin IC is equal to 1 by n. So sin IC is equal to 1 by root 3. So IC will be sin inverse of 1 by root 3. Root 3 is 1.7, which means critical angle will be less than 42 or more than 42? Less than 42. Okay. 42, right? We are comparing it to. Or I think I can use the same method which I used earlier. So let's say sin 30 is sin 30 is 1 by 2, right? So sin IC is 1 by root 3. So any idea how to compare this? So 1.713 something, right? 1.772. So this is for 1 by 2, it is. So for when I put 2 here, it is 30 degree. If I put a smaller number, this overall number will be getting bigger, which means IC will also be bigger than 30. So I can say IC is greater than 30 degree, but my angle of incidence is 30. So that means, is there any total internal reflection or not? IC is greater. I is less than IC. That means there is no total internal reflection. So when you said no total internal reflection, will there be any refracted ray or not? There will be a refracted ray. Okay, so don't get confused by the letter here. No total internal reflection means actually there is a refracted ray. You following it? Total internal reflection means everything is getting reflected. There is no refracted ray. But when I say no total internal reflection, that means it's going to go something like this. So it's supposed to go straight like this, but then it is denser to rarer, which means it will go away from the normal, so it will go like this. So angle of emergence is this angle, right? So I think by emergence they mean angle which is coming out here. So this is angle of refraction. So this is angle of refraction here. Okay. Everyone okay with this? Anybody still having some trouble? So please listen one more time. Let me explain to you. So if I had a table or a calculator, it's very simple. I can directly find the IC, right? But since I don't have it, right? Or if you have the tables, you can always check it, right? You are allowed to use tables, right? Sine tables. Then what? You will be able to find this. Okay? Then compare it and you can say whether it is total internal reflection or not. Okay? If you are not comfortable with this method, don't worry. Just use your tables. But then you have to practice now itself. Okay? You keep it for your final exam, then you will not be searching there. What is sine table? What is cos table? How to see it? Right? All those things you have to practice it now itself. Okay, so coming back to this, I think they are asking you to find the angle of emergence. But then the refractive index is known as root 3, right? So that means I can say sin I by sin R is equal to 1 by n. Okay, why? Because it is denser to rarer. So when it is denser to rarer, you have to invert it. Okay, so that means you are not supposed to put that n directly. You should put 1 by n. Okay. Is that clear or not? So that means sin I is given as sin 30. Sin r is what I am supposed to find. 1 by root 3. So sin r is equal to root 3 into 1 by 2. So root 3 by 2. So that means r will be 60 degree. That's all. Okay. So that's your angle of emergence. What do you mean by angle of emergence? The angle with which it is coming out from the normal. So if this is coming out like this we call it as angle of emergence. Six is simple. 49 is theory. Okay, try 50. Draw a ray diagram to show the image formation by a concave mirror when the object is kept between its focus and the pole. So this is a 10th standard question, right? So what happens when you keep between focus and the pole? Virtual image behind the mirror, right? All the other 5 cases will be producing real image. Only this case where it is between pole and the F, right? It will be producing a virtual enlarged image. So that's easy. So try it yourself, draw it. Using this diagram, derive the magnification formula. Derive the magnification formula for the image form. So I think we have done this in your theory. So try drawing the diagram yourself. Are you able to draw the diagram? So I think it will look something like this. So let's say this is F, this is P pole. So if I keep the object here, so something which is coming parallel has to pass through F. Lens. It says concave mirror. Which one are you trying? 49, right? 50. Okay. Sorry. Okay. I think I got confused with 49. Okay. 49. I asked you to try it yourself. Okay. So you can try it yourself. 50. A beam of light converges at a point P. A concave lens of focal length 16 cm is placed in the path of this beam 12 cm from P. So let's try to understand the question first. So look at this. What they are saying is a beam of light is focused at a point P. That's the translation for the first sentence. Okay, go step by step. A concave lens of focal length 16 cm is placed in the path of this beam 12 cm from P. So that means I am placing a concave lens in this path such that this is 12 centimeter. And the focal length of this is 16 centimeter. Concave, okay, sorry. So that means convex. So place a concave lens like this. So remember, we already had the light focusing here. Now I am introducing the concave lens in between. Draw a ray diagram and find the location of the point at which the beam would now converge. So they are asking where the beam would converge now. Right? So I think you will have to use the virtual object concept. So this point will be considered as a virtual object. Remember, what is virtual object? It's not present there, but then we assume that it is there. Okay? That is what is called virtual object. So when the light is focused here and when I introduce this, it will not be converged here, but then this converged point is going to act as a virtual object to form the next image. Okay. So let's do the formula part first. Draw a ray diagram, find the location of the point at which the beam would converge. So since this is lens, what is the lens formula? 1 by f is equal to 1 by v minus 1 by u. Right? So the virtual object is at 12 centimeter. So is this plus or minus? Plus. So for the virtual object, this is u is equal to plus 12 centimeter. Okay. They are asking you to find where the image is formed, which means they are asking you to find the v. Have they given the f? So concave lens, is it positive or negative? Negative, which means this will be minus 16 centimeter. So substitute all these things. So 1 by minus 16 is equal to 1 by v minus 1 by 12. So 1 by v is equal to 1 by 12 minus 1 by 16. So 16 minus 12 divided by 12 into 16. So 4 by 12 into 16. So 4. So v is equal to 48 centimeters. So that means, is this positive or negative? V. Positive. That means image will be formed this side or this side. It will be formed this way. So it's going to form the image somewhere here. So this is 12 centimeters. So 4 times means it's somewhere going to be here. Okay. So please try to understand the logic of this. If I send parallel rays here, what do you think the concave lens does? It will be converging or diverging? Diverging, which means it will go like this and it will be converged on this side, right? Meaning the rays are actually getting diverged this side, right? So it's actually diverging. Okay. So something was earlier converging here, now it is converging here. How come I thought concave lens is diverging lens? Compared to this, what do you think these rays are becoming? It's actually getting diverged. Okay, so compared to this, it is still getting diverged. That's the meaning of this. Instead of a concave lens, suppose if I introduced a convex lens, where do you think it will focus? It will focus here or here? It will focus much more quicker because it is a converging lens. Whereas here it is a diverging lens, which means it is forming somewhere there. Does that make sense? If you see here I didn't use any brain at all. I just apply the numbers. Take care of the plus and minus. You get the answer correctly. But what I'm trying to say here is, after getting the answer, just see whether it makes sense. Okay. Like I did at the beginning, if you take it as convex lens, everything will go wrong. So very often you folks may make that mistake. Okay, read 52, 51 and 53 are theory. So 52, radii of curvature of the faces of a double convex lens are 10 cm and 15 cm. If focal length of the lens is 12 cm, find the refractive index of the material. How to find this? Lens maker's formula, right? But take care of the minus for the R2, right? R1 is 10 means R2 you should take it as minus of this, so it will become plus. So try to yourself, I am not going to do it. 54 is also the same. 56 is also same. 55, 57 are theory. Because it says double convex lens. What do you mean by double convex lens? It's like this. So if you take one side as R1 as, if you take this as R1 which is positive side, then this must be negative. Right? That means if you say one radius is 10 cm, the other should be minus 15. Is it making sense? This is what we used in your, which derivation did we use it for? I think it was refraction through a spherical surface. Right? Somewhere there we used this concept. Or maybe after that. Okay, so simple formula substitution, so I am not going to do it. Try it yourself. What I am trying to do here is, I am trying to walk you through all these questions to show you that all these things are manageable questions. It's not very difficult. But if you don't try it now, if you sit in the exam and try it, nothing is going to come out. But if you try it now, you will be able to do it in the exam. Okay, so 54, 56, I will leave it to you. So try it yourself. 52, 54, 56, all these things are based on the same logic. Okay, read 55, 58. 58 is also very easy. So read through it and tell me how to do it. The following table gives the values of the angle of deviation for different values of angle of incidence for a triangular prism. So they are given angle of deviation as 60, 50, 46, 40, 43, 50. For what value of the angle of incidence is the angle of emergence likely to be equal to the angle of incidence itself? Did we study some special case when we studied the prism? We studied something called minimum deviation. What is minimum deviation? Yeah, so I told you there is some experimental finding which goes like this. So this is my del, this is my angle of incidence. So as I keep on increasing the angle of incidence, there is one point where the deviation will be very minimum. After that again it will increase. So look at the table and see what happens. The angle of deviation is going to 60, 50, 46, 40, and then again it is starting to raise, right? So that means this is a point where when the del minimum is, the angle of deviation is minimum, We said that it's a special case where the refracted ray will be parallel to this base. Folks, remember that? And then I told you, so R1 will be equal to R2. This is angle of incidence I, this is angle of emergence E. If I say R1 is equal to R2, what can you say about I and E? I and E will also be equal. Right? So this condition happens only when del is equal to del minimum. I is equal to E, R1 is equal to R2. So go back and study the theory, okay, only then it will make sense. That's the reason, you must have seen something like R1 plus R2 is equal to A, and then we would have written it as R is equal to A by 2. Then we would have said what is the angle of deviation, by the way? I have to extend this line. So this line was supposed to go like this, but then it has been bent like this, which means this is what is called angle of deviation. So as I keep on changing the angle of incidence, the del will also change, and there is a particular point where del minimum happens, and that point is all these things happen. Okay. So you have to go back to the theory and study it. Okay. So that means, now tell me the answer. For what value of angle of incidence is the angle of emergence likely to be equal to the angle of incidence itself? So when will that happen? What is the del minimum from your table? 40 degrees, right? Angle of deviation, sir, talking about deviation. So del minimum is happening at 40 degrees, which means the corresponding angle of incidence is 52 degrees. So the angle of incidence will be 52 degrees. Draw a ray diagram showing the passage of a ray of light through this prism when the angle of incidence has the above value. So all you have to do is draw this. And your line should be parallel. So this refracted ray should be parallel to this. Okay, so I think we have done quite a bit of 2 marks today. So let's go to 3 marks. So let's try the first one. First one is easy. Monochromatic light of wavelength 589 nanometer is incident from air on a water surface. If mu for water is 1.33, don't get confused with mu. So as I said, some books may use mu instead of n. Okay, both are same refractive index. Find the wavelength, frequency, and speed of refracted light. So how to do this? What formula will you use? What formula? They're asking about the refracted ray. Very simple formula, right? Refractive index is equal to C by V. That's all. So find out the V and then you can find all the other things, right? So do it yourself. Mu is equal to C by V. C is known, mu is known, which means you can find the velocity in the medium. Once you find the medium, V, only if you are thorough with the theory, all these things will make sense, okay? So if you have not studied the theory, nothing is going to make any sense to you. So refractive index n is equal to c by v. So n is given, c is given, which means I can find the v. Once I find the v, I can use v is equal to mu lambda, right? So lambda is given, v is given, find out the mu. That's all. What is lambda? 589 nanometers. That's all. Okay, can you do it yourself? So if you know this, you should be able to do it. Anybody having any doubts, any issues? A double convex lens is made of a glass of refractive index 1.55 with both faces of the same radius of curvature. Find the radius of curvature required if the focal length is 20 centimeter. So they are asking you to find the R. So same thing. So which formula should I use? Lens maker's formula, that's all. So 1 by f is equal to n minus 1 by r1 minus 1 by r2, but the radius is same, which means this will become 2 by r. Why 2 by r? Will become minus here. It means it will become 2 by r. Refractive index is given, focal length f is given. Refractive index is 1.55. So did we get the same problem earlier also? There also it was 20 centimeters, right? So I think this is given, you are supposed to find this. So, okay. So I'm not going to be spending time on all these simple things, so I expect you to do it yourself. So take down the formulas at least, try it. Try 62. What? 2 into 10 power 8. Okay. Everyone getting that? Everyone getting 2 into 10 power 8 or 62? Ray of light incident of face AB of an equilateral glass prism shows a minimum deviation of 30 degree. Calculate the speed of light through the prism. So del minimum is given as 30 degree. They are asking you to find the speed of light in prism. So that means V2 is asked. If I know the refractive index, I can find the velocity. Right? So how to find what is the link between refractive index and del minimum? Any formula you know? Prism derivation, you folks have still not studied. So sine A plus del minimum by 2 divided by Sin A by 2 is equal to refractive index n. This is a derivation which you must have studied. Okay. So did they say it is an equilateral triangle, glass prism? Yeah. So that means what will be A? 60 degree. Del minimum is given as 30 degree. This is again 60 degree, which means I know everything on this side, which means I can find the n. Once I find the refractive index, can I find the velocity? How to find? What is the formula? N is equal to C by V. So C is known 3 into 10 power 8. So find out the V. Okay. Usually all these glasses, as I told you, it's very close to 1.5 refractive index. Okay. So as soon as you get the value, make sure you are getting something close to 1.5. Root 2. So yeah, that should be okay. 1.4. Root 2 is 1.4. It's close to 1.4. Minus root 3, root 2 by 2. Sin 30 is 1 by 2. I think it will be root 2. Sin 45 is 1 by root 2. This is 1 by 2. So 2 goes on the top. So 2 by root 2, which is root 2. So n will be close to root 2. Okay. So it's a huge chapter, okay, as you can see. The number of questions in this chapter alone is like 103 questions. Okay. Find the angle of incidence at face AB so that the emergent ray grazes along the face AC. Yeah. So they're asking you to find the angle of incidence here so that this is going to go something like this. What do you mean by grazing the surface? Just touches the surface, right? So I think you will have to find R1 here. This side it will be R2. This side it is 90 degree. Right? Let me redraw this a bit bigger. So they are asking you a situation where angle of incidence is I. Since it is equilateral, this is 60 degree. So they said that it is grazing the surface, which is 90 degree, right? So how to proceed after this? R1 will be equal to R2, why? Now that is for the first part of the question, right? I don't know if you can apply the same concept here. Ch9, are you listening or not? Continuously hear your voice. So let's see, R1 plus R2. How can I write this? So now look at this. Sin I is what I want. Sin I by sin R1 is equal to refractive index, which is root 2, right? So we found it as refractive index root 2. Or is it a different question? Find the angle of the face so that the emergent face, so that is root 2. This side it is sine 90 divided by sine R2 is equal to, if I put this by this, again I should be getting the refractive index. Everyone listening? If I put sin I by sin R, I will be getting root 2. If I put, this is, for this thing, right, this is my angle of incidence, this is my angle of refraction. Which means if I put sin R2 by sin 90, I should be getting 1 by n, right? Or I can flip it and then write it as n. So let me write it one more time here. So sin R2 divided by sin 90 is equal to 1 by n. Or I can flip it and write it as n, which is root 2. Which means using this you can find the R2. And then once I find the R2, I can find the R1 and then substitute it here and find the I. That's the way you should do it. Okay, so take it down, write yourself. You get the idea? You form an equation here, you form an equation here. R1 plus R2 is 60. That's another relation which I know. So connect these two things and find out the I value.